Multiplying polynomials containing several variables. We have a couple different strategies for multiplying polynomials. One that we talked about was to use the distributive property. I'll do that for example A. I'm going to start with this 3x and I'm going to distribute it to each term in the second polynomial one by one. 3x times 2x is 6x squared. Then we'll move on to the second term there. I've got 3x times 7y. I don't have variables that match up, so I'll just multiply the 3 times the 7, which is 21, and then I've got an x and a y sitting there. Moving on to the third term, 3x times a negative 9 is minus 27y. Now I'll go to the negative 1 in the first term and multiply it by the 2x. So that's a negative 2x. Next, going to the 7y, that's minus 7y. And then going to the negative 9, I've got plus 9. All right, looking at this, I don't necessarily see any terms that match up. So I think that this is my final answer because I don't have anything that can be combined together. As far as writing this in order of the correct variables, there's not really an exact science to this. We just try to write anything that's got higher exponents in the front and then any number by itself with no variables at the end. So we would just kind of leave our final answer like that. The other strategy that we talked about for multiplying was using a box. So let's see if that'll work for example B. I've got 2 items multiplied by 3 items. So let's make a box that's 2 by 3 here. I'll have x plus y, x squared, negative xy, and then y squared. So I'm going to go and I'll start here with this x and multiply it by the x squared to start. That'll give me x cubed. Then we'll move to negative xy. Let's see, that'll give me a negative x squared times y. Then x times y squared is a plus xy squared. And now we're ready to move down to the second row. This is a plus x squared times y. Negative x y squared. And then our last terms are plus y cubed. One of the reasons that we talked about doing this is that it's easy to see the terms that are alike kind of on the diagonal, and that's happening here. I've got these two terms. I've got x squared y, so those match exactly. Those can be matched up. And then we've got xy squared here. Those match up with one another. So let's write our final answer here. It looks like for our final answer, we'll have x cubed. Looking at the term in that first diagonal, I've got one that's a positive and one that's a negative, so I think that they are canceling each other to be 0. And that same thing is happening for that second diagonal. So it looks like this is just x squared or x cubed plus y cubed.